outrageous laundry detergent.
Chemistry time, Hadley. Today we're talking about solutions. That slimy lotion is going to make me drop this marker.
It is very slimy.
Okay, so we're going to talk about some different types of mixtures here. So solutions is what the general topic of this video is, but first, before we talk about solutions, we're going to talk about mixtures in general. So you'll remember from physical science or other times of your life that there are different kinds of mixtures, right? Do you remember what the two broad categories of mixtures are? Homogeneous and heterogeneous. So solutions is the title of the lesson, but we're not talking about solutions yet. We're talking first about heterogeneous mixtures. Hetero meaning
opposite?
Not necessarily opposite, but different.
Different.
Heterogeneous means they come from different things. Hetero, different. Gene, this little thing here, like Genesis, means where it's originated, right? So they come from different things. Whereas homogeneous means they come from the same thing, and that's not a perfect. I mean, that's kind of how the word breaks down. But we can think of it this way: when you can tell the different parts of the mixture apart, it's heterogeneous. And when you can't tell the different parts apart, it's homogeneous. Anyway, so some examples of heterogeneous mixtures. First, we're going to talk about we're going to talk about three of them.
Wait, so what's the definition of it again?
Heterogeneous mixture is one where you can tell by some means you can tell the different particles from one another. Not necessarily by sight, but when you can tell them from one another.
So like sand.
Yeah, if we had a mixture of
Sand and
clay, sure. Sand and clay would be a heterogeneous mixture, right? They remain distinct. They're different from each other still. They're hetero from each other, right? The way you can remember heterogeneous and heterosexual is that those are both different. If you're heterosexual, you have an attraction to the opposite or the different sex, right? So heterogeneous means they have different composition throughout. So first we're going to talk about suspensions. We're going to take a detour and talk about Thixotropic mixtures, and then we're going to talk about colloids. So first of all, suspensions are mixtures where we wouldn't really use the word solid, that's what's tripping me up, but they're mixtures where one substance is suspended in another substance, right? So one substance, I'm going to try to use not with the word suspended because that's part of the word suspension. One substance, we could even say it's floating in, kind of. Floating in another. The classic example of this is Italian salad dressing. I'm going to have you think of an example that isn't that. But as an example, Italian salad dressing is a suspension. The chunks, first of all, the oil and the water are not mixing together at all. Yeah. When you shake it up, it acts as a heterogeneous mixture because the oil is suspended on the water, and the little like red pepper flakes and the onions and the little spices they eventually settle to the bottom, right? And that's the hallmark of a suspension, is that the particles eventually settle to the bottom. What else might that happen in?
Have you ever made Asian salad?
I'm about to think about Asian salad. I don't think I've ever made it, but I've eaten it with ramen noodles in it and cabbage and slivers on it.
You should make it.
I don't know that I will. Anyway.
The sauce that you mix together, it's like oil.
Is it still salad dressing? Can you think of an example that isn't salad dressing? Well, lava lamp. Yeah, we can think of a lava lamp as a suspension. Good. Your salad dressing was a good example too.
It's really good to just drink it. Have you ever tried it? Just drink it. Just drink it. It's like a little drink.
A lava lamp does count as a suspension, right? It's two distinct things that the reason we have a lava lamp is not so that they can just separate, but they do just separate, right? Let's now talk about, we're going to take, like I said, a detour. We're going to talk about Thixotropic.
Which is a part of the solution?
They can be either a suspension or a colloid, but they're types of heterogeneous mixtures. But a thixotropic, I'm sorry, I shouldn't have said, yes, mixture. Thixotropic mixture is one that when force is being applied, there's always forces applied to it, but when an unbalanced force is applied to it, it behaves as a liquid, but when it's setting still, it behaves as a solid. So, solid, when sitting,
is that a C?
comma, Thixotropic.
Okay.
Solid
Like
when
gallium?
sitting, no, not quite. Let's get solid when sitting, liquid when moving. I don't know. That's a pretty facile definition. Like that's how you might describe it to a second grader. But it works. A classic example of this is like toothpaste, right? So when you squeeze toothpaste, it squirts out like a liquid. But when it's sitting on your toothbrush, it's not like it runs all over the place, right? It just sits there as a solid wood. Can you think of any other examples of a thixotropic mixture?
Hair gel.
Hair gel, yep, definitely. What else? Any non-beauty products? Yeah, lotion. Lotion, it depends on the lotion, but yeah.
Like dish soap, maybe?
I think dish soap's probably more, it's not going to behave
it's
as...
not a solid.
Yeah, it's not going to behave as a solid system.
Well, like cream. You know, like cream, it's a solid.
Like whipped cream?
Like whipped cream?
Like whipped cream, yeah. Yes. That would count as one, yes. So thixotropic mixtures, we'll leave it at that. But yeah, it behaves as a liquid under some circumstances and a solid under others. And then the other type of heterogeneous mixture we're going to talk about is a colloid, which the suffix oid means like, and the col part comes from the same root word as collage. You know what a collage is?
Yep.
Collage is a type of artwork you have done where you have done what to different things?
Put them all together.
Put them with what? What have you put them together with?
Glue.
Glue. Yeah. In fact, I forget exactly what the word is, but the colloid and collage both come from the French word for glue. Anyway, so a colloid, they're not all glues, but colloids have smaller particles and suspensions. They don't separate. Do not separate upon sitting, where a suspension does. Right? If you leave a suspension sitting, it will separate, whereas a colloid, it doesn't.
An example of this.
Paint would be a colloid. Milk is a colloid. So they're particles. They're not fully incorporated. In both of those cases, paint and milk, there are little fat globules that you can't even see with your naked eye.
Don't they do separate?
Milk?
Yeah, milk sit out so long it's supposed to curdle.
Well, yeah, that's a chemical reaction. Though. The curdling of milk is a chemical reaction. But you're right. Raw milk, like if you squirt it right out of the cow, that will separate because it's not a colloid. They do a process to milk called homogenization, where they force it to be a colloid. They add stuff to it and they blend it up so that it behaves as a colloid instead of as a suspension because it's more beautiful for people. But yeah, milk like you buy at the store is a colloid because it has little globules of fat suspended in water, basically. In paint, it's kind of the exact opposite. It's a whole matrix of fat. Like the most of it is fat. It's usually linseed oil, and then it has little blobs of oil-based paint in it or oil-based dyes.
Okay.
If you've ever painted with oil paints, have you ever painted with oil paints? They all have things like cadmium orange is the name of a paint. Ochre. They're the name of the substance that's dissolved, or not dissolved, but colloided, right? It's dispersed is the verb we use. Just like we have suspended for this, we say that the cadmium yellow, for instance, is dispersed in a medium of linseed oil.
Okay.
So the colloids don't separate, suspensions do, and then thixotropic mixture can be either one of these, but it basically behaves as a liquid under some circumstances and as a solid under others. Look with me on page 476. I think this is the coolest chart. There's this chart called types of colloids. If you're watching it on youtube.com, you can type in types of colloids. You'll find this chart too. But look on page 477. Look at the types of colloids. So it has here the category of colloid, an example of it, what it's dispersed, what kind of particles are dispersed, and then what the dispersing medium is. So for our paint example, the dispersing medium was oil, right?
Right.
So that's a liquid. And the substance that's being dispersed was cadmium yellow, which is a cadmium salt, which is a solid. So we would call that technically, look here, dispersing medium liquid, dispersed particles solid, we call that a sol. Look what are some other examples of sols. Blood, gelatin. Are you with me?
Yes.
So if a solid is dispersed among liquids, in blood, what is the solid that's being dispersed?
Calcium?
Water?
No, that's not what's being dispersed. What solid chunks are in blood?
Clots?
Not necessarily, but what are those made of? Say it again. Say it louder.
Water?
No, not that one. The right one. You were about to say it.
Cells?
Cells?
Cells.
Cells. The
Well,
red blood cells
yeah.
they're not fully solid, but but they behave as a solid. And then the liquid, what we call the liquid part of blood. Aren't you in anatomy or something?
Yeah, but we haven't learned about
Yeah,
that.
what's the liquid part of blood called? You know. Plasma. Plasma.
Plasma.
Did you know that?
I actually didn't know that now.
Now you do.
No.
So the solid red blood cells, they're not totally solid. The solid red blood cells are dispersed in liquid plasma. Look at this. A solid sol was when a solid is dispersed in a solid. The example here is called colored gems. So a gemstone, like ruby, is a matrix of mostly corundum, which is a mineral that is aluminum silicate of some kind or other, and then it has dispersed in it particles of iron oxide that make the ruby red. So most of it is aluminum silicate, but there are dispersed little pockets of iron oxide that make the ruby look red. So gems are a type of solid sol. Emulsions, it has solid emulsions, solid foam. You can probably, without even looking, don't look at that, look at me. Without even looking, what's a foam probably? What state of matter dispersed in what state of matter?
Liquid dispersed into a solid.
Try again.
Okay, solid dispersed into a liquid.
Try again.
What?
What in a foam? What's in it? Like what's making it foamy? What other state of matter
Gas.
is gas? Gas dispersed in a liquid, right? If you wanted to make a foam, where do you see foam at in your life?
Well, you put mousse in your hand and then
Yeah.
Well, okay. Think about how you can make a foam.
make a foam.
Yeah,
Make
how can
foam.
you make foam? Like, what can you do in your? You've probably
Soak
done it
your
like
spit.
several times. Yeah. Okay, both of those. We'll start with the soap.
Bubbles.
So when you rub your hands together with soap, what you're doing is you get the soap, which is a liquid, and you rub it with the water, which is a liquid, and as you rub, it's incorporating air from the air into it, which is a little tiny bubble. That's making a foam. Spit. When you work out some spit in your mouth, yeah, that's gross. When you rub some spit, the saliva is liquid, but the reason saliva you always think of as bubbly is because there's air in your mouth that's getting worked into that liquid. That makes it a foam. And then we have two other things. Solid aerosol and liquid aerosol. So if it's a solid suspended in gas, we call that a solid aerosol, and if it's a liquid suspended in gas, we call it a liquid aerosol. A solid aerosol is like smoke, right? They're little tiny, you can't even see them, they're so small. Little tiny chunks of wood or ash or cinder or whatever floating in the air. That's what smoke is. And that's a type of, that's like I said, an aerosol. Nope, your breath will be a liquid aerosol because it's little tiny droplets of liquid water.
Oh, okay. Okay.
Okay. Let's talk now about homogeneous mixtures. So this all took a long time, but that was homogeneous mixtures. And now solutions really only applies to these. These are homogeneous mixtures. We almost always can think of homogeneous mixtures as synonymous with solutions, right? A solution is always a homogeneous mixture. A homogeneous mixture is not technically always a solution, but more or less it is. We just think of those things as synonymous. So what's different about this is that we can't tell solutions. We can't discern, we can't differentiate with the naked eye or with anything else between the solute and the solvent. So the solute is the what?
Is the dissolver.
Try again.
Dissolving.
Yeah. Dissolved substance. And the solvent is what?
The dissolving.
The dissolving substance. So if we have salt water, the easiest solution to relate to, substance, dissolving substance. If we have salt water, the easiest substance or the easiest solution to relate to, what's the solute?
Salt.
And the solvent?
Water.
Okay, good. If one thing dissolves in another, it's said to be soluble. Soluble if it dissolves in a given substance. I should phrase more like an English language sentence. A substance is soluble if it dissolves in another given substance. So I might say salt is soluble in water, right? Calcium carbonate is partially soluble in water, or we could maybe even say slightly soluble in water. Copper carbonate is insoluble in water. So it's soluble if it does dissolve in that thing, but it's insoluble if it doesn't dissolve in that substance. You notice about the examples I was giving that we have to specify what the solvent would be, right? Salt is soluble in water, but it's only partially soluble in fat, like olive oil, for instance. So usually it's generally in inorganic chemistry at least. In inorganic chemistry, it's usually salts that we're talking about being either soluble or insoluble. But if it's a liquid, if it's two liquids that mix together, we call that miscible. Two liquids that mix in any ratio are miscible. An example is alcohol and water. Right? We can have a solution that is 90% alcohol and 10% water, or 10% alcohol and 90% water, and anything in between those. Right? We can have a solution that's almost 100% alcohol and almost 0% water, and anything in between those, right? Because they're infinitely miscible. They can go in any ratio to one another.
Okay.
That's what miscible means. Whereas, I probably don't even have to tell you, but what's immiscible probably mean?
When two liquids can't mix.
When two liquids can't mix. Like what?
Oil and water.
Oil and water are immiscible. In no amount can those two things mix. There's another kind of cool table on page 479 about examples of solutions. It doesn't have to be a salt dissolved in a liquid, right? So for instance, if you're a fan of the LaCroix, have you ever heard of LaCroix?
Yep.
Are you a fan of it?
Yep.
What about you, Hadley?
I've never heard of it.
Oh, whatever. Well, I'm just going to talk to her then. LaCroix is cool. We like that. That's a club that we're in. LaCroix is, first of all, it's water primarily, right?
Yeah.
Water is of these things, water is the what?
Like the main one? What?
Yeah, what's the main one called?
The solvent?
The solvent. Water is the solvent, and then there's two solutes. What are they in a LaCroix? In most LaCroix? What are the two solutes?
Would carbon be one?
Yeah, carbon dioxide, right? The bubbles.
Yeah.
Carbon dioxide is dissolved in it, and what else
There's
is?
probably some sodium in it?
No, there's flavorings in it. They're like like the cherry or
Yeah.
kiwi lime or whatever. I don't know. So the solutes are the things that are dissolved in it,
Okay.
and
Which is the flavor?
which is the flavor
And
and the
carbon
bubbles,
dioxide.
right? So when it's sitting in the can, it's under pressure, and the carbon is fully dissolved. If you could have X-ray vision, you would see that inside that can of LaCroix or Coca-Cola, there's no bubbles
It
at all. It
just
just looks like a
looks like
regular
water.
old dang liquid. Once you pop it, the pressure is alleviated, and then bubbles start to come out. And basically, they continue to come out of solution. They're falling out of solution until the pressure inside the can is equal with the pressure outside of the air. And then the LaCroix or the Pepsi Cola or whatever is flat. Exactly.
Which means there's no more bubbles left.
Right. I think
That's
we.
interesting. I never knew that
Yeah,
before.
yeah. That's it for today. You guys have questions at all?
Nope.
Do you have questions at all?